Welcome to today's webinar. The topic today is Geo-Zone tool, retrieving load zones using Python. My name is Andreas Hörold. I'm responsible for marketing and public relations. Now, for example, the German and English webinars, technical content of the website, customer projects, and so on. I will be the moderator today, and I will answer your questions during the webinar. My colleague Eike Hartmann will be the presenter. He's member of the customer support team, responsible for the Geo-Zone tool, and also responsible for the development of the add-on Timber design. You can ask questions when you press the button with the question mark, then enter your questions in that field, press send, and I will receive your questions and I will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's for the moment all from my side. I hand over to Eike. Eike, you can start.
Thank you, Andreas, and also a warm welcome from my side. Today we're going to look at the Geo-Zone tool, and we'll start with the web version. Afterwards, we will look at the documentation and the installation of the Dlubal API, and I'm going to do some examples and show you how the answers are structured. We'll start with the load values, getting standards, then exporting a PDF, and in the end I will show a more complex example. This is for you to see what might be done with the Geo-Zone tool API in combination with the RFEM API. Let's start with the website. Here you see the main website, and also there's directly a banner that is showing us that we have a new design of the Geo-Zone tool. If we are going under solutions and online services, we can jump right into it. Here we have the Geo-Zone tool. You see on the top left corner, there are the different loads. Right now we are in snow loads and have the standard, the European standard, selected for the United Kingdom. I will just jump to Germany for my example because I'm from here and I know these maps best, and we'll show you the rest. On the right side you can see how many clicks I have left. For now I have 1500, so this will be enough for us to show this. On the left side we can see enter location. There you can search for a location directly or just enter the coordinates, and below we have the geo coordinates listed with the street, city, and latitude and longitude. For the billing, I can say every time you search for an address, you will get charged for 1 click. But if you select the standard or the loading at the start, this will not charge a click. Here you can see I have 1522. If I switch from Germany to Estonia, this will stay the same. I go back to Germany. If I click into the map and go to Bremen, this has lowered and I see different values. This is the same for the export. I'm just coming through. For the load of the snow load, we can here see our zone for Germany and the characteristic value of the snow load. On our screen we can see the map, and also on the top here the legend of this map. On the left bottom side, we also see different functions we can use. There's the screenshot function. We can save the data as an XLS file and also print out the data as a PDF. This print and also the other functions also cost 1 click. We have some other functions, but I will get to them later. Below, we have some different links, for example, for the webshop or the documentation. And what I think is also important are the sources you can see here. And you can see, for example, that for Munich, we have different snow loads. This is a regional example inherent in the German way of doing these, and you can look at the sources and see here, okay, there we have different documents. They will vary for every country and every annex also. Let's go through the different loads. We also have the wind load here, where you can see the fundamental basic wind velocity here and also the basic velocity pressure. Now we're looking at this other functions. Here you can see we also have the profile. Here is the wind profile, where we can see that there is the mean wind velocity according to the height of the building. At the start, we have some parameters where you have to choose some manually. For example, here we have the terrain category and the structure height. I'll set this to 25. And the fundamental wind velocity is taken from the position you have. If you want to use this, I would suggest to look at these values yourself. Just jump over to the results. Here we have the mean wind velocity, turbulence intensity, and the wind pressure. And we can see them in a diagram here on the right side. The last loading for Germany is the seismic one. Here we see the map has changed, and we see the reference value of peak ground acceleration at the bottom. Okay, at this point we don't have any. Let's jump over to this location and see the value has changed. What I want to highlight here is that for the seismic actions you have different maps with the different return periods, and we're not here at 475 years. And at the bottom you also can look at the subsoil class. I'll jump over and see here we have the subsoil class T with the different reference peak ground acceleration of 475 years also displayed here. What I would also like to highlight is that we also have seismic profiles. You can open this here and also find on the first page some input parameters like the spectrum shape and also the spectrum direction. I'm not gonna dial in anything here. If you're interested, I suggest to look it up as well. You get here the frequency, the spectral acceleration according to the period, and also some nice looking diagrams on the right side combined with a map. We are currently working on the possible to export these profiles, wind and seismic profiles too. So in near future, or if you're watching it in delay, you might be able to get access to this also later on. And if you have exported it, or if you are using the API, this will also be made available there. What I want to show you next is when you go on your account in the extranet and look under Geo-Zone tool, you will find every click you have done, or every activity you are doing listed for yourself, also for the company, and will find the consumed clicks and the available clicks here under billing, and also whether this service is active or you have a subscription like I have. Then we will jump over and look at the API and start with the documentation and where you will find it. First, I'm going back to the homepage and look at our products. There we have the Dlubal API and the API documentation. I will jump right into it and go on explore the API. Here you can see in the section navigation, there is the Geo-Zone tool listed, and also here down here, because today we just want to look at the Geo-Zone tool, I'm gonna jump into this part. Here we are seeing the documentation, and what is crucial is that we are using an HTTPS endpoint here, which we are referring to with our client libraries, which we have in Python and C#. And yeah, how we are going to install it, I will show you on an example, and everything you as we need. If you have any questions, you can look into this documentation. We always try to keep it updated to our current development and that it answers every questions. What I want to show you too is that we also have this documentation in PyPy. Let's look. Here we have the Geo-Zone tool. Here you can also see the history and the current version. This is obviously for Python. We have the same in NuGet, and I'll look it up here as well. Here we have also the Geo-Zone tool and have the documentation for C#. One thing I also want to highlight is that we have a status page where you can access whether our service is online or whether there has been maybe an outage before. This is a new development where you can make sure whether our server is running, or maybe if you have another problem in your code, or maybe on your server. Okay, let's jump over to my development environment. I'm using Visual Studio Code, but you can use the environment you like. Let's open the PowerShell terminal and go through what you need for the installation. As you can see, I have a virtual environment open. I'm not going into detail how this works. You can find plenty of examples online if you want to set up your environment. First, how can we install the Dlubal Geo-Zone tool API? Therefore, we use pip install Dlubal API.geozone tool. Let's see. Oops, this was wrong. Let's see how this works. And we can see, okay, I already have this installed. Here we see requirement already satisfied. I could update this version, always jump between versions. So if you don't update your package, you will always have a functioning code. And we also try for every update not to break any existing code in this. You need Python, at least Python 3.11 for using this API. I'll look at my packages with pip list to see what I have. Here we see the Dlubal API. If you install the Dlubal API, the Geo-Zone tool API will install as well, but you can also install the Dlubal API, Geo-Zone tool API without the Dlubal API. Here I see my version. This is fine, so I will close this. And we'll start with my first example. Okay, what do we see here? Here I have the first example. It will be get user data. Here I import the class from the module and use it here with a token. Here you can see this token I'm showing is the same as the Dlubal API, general API. I am showing it here in the presentation, but would plead to you to not show it in public, because if you show this token in public, or if you send it to anyone, they can use your requests, and for the Dlubal API and also for the Geo-Zone tool API. Where you do, I will show where you get this token again. There we go into our account, go to API and Cloud, API 2, and here I have my API keys. If I go on modifying this, I will see the complete API key and can use it in my development. Let's jump back. To our documentation. Oops, I was a little bit wrong here. This could have been done faster, but let's see. There we have our RP operations, and we will start now with the simple get user data. And here we see again that we have our client libraries in Python and C#, and we also have GraphQL, because you can also use it directly to communicate with the server. Therefore, I would like to show you a small diagram to visualize how this is working. Here we are working now with our client library in Python, and this is using a function call in graph and wraps it in a GraphQL query where you have it as a JSON post text, and we'll send it to our HTTPS endpoint, which I showed before. This is our server communication, and therefore we need authentication with the token for most of our requests. And now then we get from the server a response in a text format, in the JSON text format, and this will be translated as, or will be given out from our client library as a data class object, where we have a key and the value, and can use it directly in a preformed structure that we are using for every data class object we are giving out. Before I am going to continue, I want to highlight that the requests for the Geo-Zone tool API are not the same as the Dlubal API. This is a different billing system. You can buy the request in the shop, or you have 3 free requests every 72 hours you can use. So let's jump back to our development environment and look at our first request. We have our method get user data, which we save as variable user, and print in this variable the remaining clicks we have. As a result, we can look at our email clicks. For this example, I just want to show the clicks that I have. So let's run this little program and see what we get in the terminal. Okay, I'm having a lot of clicks. For this example, we actually do not need the token, so we could leave it out and get the same here. But for my showcase, I wanted to have it here. Let's jump to our first real example and how to get results from the Dlubal API. For these results, we take the get load zone characteristics method, and we'll start here again with our token, save it as variable. For this method, we need necessarily the address or the load zone type. I have a wind typed in here. And as the address, I have coordinates. This is the coordinates am Zellweg 2. This is the headquarter in Germany from Dlubal. We could also type in the text here and take this as an address, so both is possible here. We also have optional parameters. I'm currently not using them, so I have them as a comment, but here we could use a specific layer. If I don't specifically want to get a layer, I get the active layer and the first answer of this active layer. For wind, this is probably everything we want to know, except if you want to maybe look at an outdated norm or see what else we have here. But for the seismic actions, it might be possible to might be necessary to get other return periods or maybe directly get the soil class. For this example, I'm going to run this and will print first the result code and then the type of results. Let's see what we get. Okay, the result code here is saying, okay, so the answer worked. There we would get an error if it doesn't. And for here we get the class and see, this is characteristics response MIA type class. To explain further how the answers are going to be structured, I will show a PowerPoint, but before, let's see the full string we get from the server. Okay, here's the class, and there we get the complete answer. We will see that it is layered, and let's look at the different layers of this structure. So the first response is the class I just showed you. Here we have the code and the message, and inside we also have the geolocation. This is on different list with other values. Here we have all these, the city, the street, and the zip code, and also the coordinates. In another structure, we get the standard and the annex in a different layer. This is kind of one layered branch, and here we get another one where we have the standard and the annex and the load zone ID. One further below, we have one branch with the zone and the characteristics. The zone might be the wind zone number 2 and an ID for it. And in the characteristics, we have probably what we mostly seek, the value and a name and also the corresponding units. This structure is a JSON text structure. Here we see an example. I will show this in my development environment again, but here we see the different layers. Let's jump back to my environment and I will show you the layers there. Okay, here I have the answer as a JSON text. I saved it in JSON format. This is not automatically happening, but I wanted to show it to you so you can understand the structure a bit more. Here we have our first layer, the code here, and the attribute, and the result is okay. Then we have one layer beneath. We have also two lists, geolocation and characteristics. Let's jump into this. Here we see our keys and values of different objects, the altitude, latitude, longitude, and also country and street, etc. And let's close this again and look at the characteristics, where we'll see the layers I just showed you in my graphic. Here we have the standard, the annex, and then under zone characteristics we see the ID, and there we have our zone. This is the zone number 2, and we see our characteristic values. This is the snow value, but it will be the same structure for every answer. So if we would have the JSON from our request here would be another value, and therefore you can be sure that we are looking for characteristics and calculated value. They will always be the correct name and the correct calculated value, no matter which type of load zone we are looking at. Okay, let's jump back into the code and start the other part we have here. Here I'm just saying what I'm going to print. We have the result geolocation city. So we are looking in our result, then into our geolocation here, and are going to print out the city. And here we are taking a for loop, and there we're getting in result characteristics, print the standard and the annex, and also afterwards into the zone characteristics. There we want to have the zone value and going to print it out, and in the end we get the zone characteristics. There we want to have the name and the calculated value for our wind load. Let's see what is the result of this. Okay, here we have it. There we see our basic fundamental basic wind velocity and our basic velocity pressure, because we have two calculated values after each other. We also see our zone and the standard and the annex, and here seems to be our city. Okay, that's it for our first example. But before I want to continue, I just want to show you that the same code for the seismic loads, you will get also these values. This is the benefit of our new structured response, that you can get the results for everything with one structured code, because we have a well-structured answer now. Okay, here we see we got the same result first, and then we get the peak ground acceleration value instead of the values for the wind wind loads. Okay, so that shall be it for this part. And now one addition also to our results is that when you want to get results for the ASCE 722, the American standard, specifically only for the seismic design, we have to use a different method because we could not get the data into our database. So we use, or you have to use a workaround here. There we get use the API from the hazard tool. The start is the same. We do not need a token here, but you get a little bit different input, which I will not show in detail right now. Let's start this and see what result we are going to get printed. Okay, this is quite a lot, and to get an overview, I have here a more structured response, which I will not explain in detail, but there you can see what we can get. Here we can see the results on the bottom printed out. We have the spectral acceleration for various periods, short one and different one, and also here the seismic design category is D for this place. What I will show you too, all this data got plotted into two plots here, and there we have the multi-period response spectrum and also the two-period design spectrum. Yeah, that shall be it for this part. If you want to explore it, feel free. So now finally we will continue to our second example, and this is the find location. The find location does exactly what you might think. You will, with this method, get the results for the city, and also the coordinates will be displayed. Let's see this. I am not going into detail. Here we can see we also don't need a token here. So here we have Dlubal Software GmbH 2 am Zellweg. This is our location. What I wanted to highlight here is that you might get more than one result. This is because when you're not quite specific, or there might be two results, you will get them and can evaluate which one you want to take, or you just take the first one. This is why I wanted to highlight this here again. So the next example we are looking at is get a load zone standards. I will jump right into our documentary at the right position. Here we see it in Python, C#, and GraphQL, because you can use these both client libraries or use GraphQL to directly access our HTTPS endpoint. What we see also in here is that we have input parameters and see, okay, our country code is required. We do not need a language, but we might use one if we want to. Now let's jump back into our environment. And see the code we have for this example. Here we have the get load zone standards and got the country code here. We might also implement the language. And now we're gonna run the script and see what results we are gonna get. Okay, here we have again our class This is the load zone standards response type in this example, and here we have the full response string. Let's see again how this is layered in our JSON document. I'll jump right into it. Here we have at our first layer the country code, and then we have our type groups. There is snow, wind, and earthquake as load type, and directly in there we see load zones. Here we have the standard and the annex with also different layers. With here you see ID and names, and also why do we even need this is that we have maybe different standards integrated, or if you want to know which one we already use, you can use this method and see. For example, here for snow we have the Eurocode, the current one for our country Germany, but we also have one older. Here's the DIN that you can use. Another use case can be seen here for our earthquake results. There we see that we have our standard, and there are different types directly, and here we see our annex name is okay. 20. This is the current one because this one is older, and we see here in our layers we have different IDs. This is what I was talking before. Here we have the 475 years, and also you can choose different ones as a result, or even the subsoil class directly. This, and with the ID you can get to maybe the subsoil class directly without having to try it out. So let's see ourselves in this example code. We look at the seismic load zone type. This is again our method get load zone characteristics we used before, and here we will print. I have our layer ID. I've already entered it in 832, so we use this optional parameter to get the result we want to have. Okay, I don't want to print the full result, but let's see the result status code and run the script. All right, so we have here our zone. This is the subsoil class. Here is R, and the peak ground acceleration of 475 years here is also listed. This is what we would like to have for this result. Okay, so now we know how to get results for different types, and also to see what types are there at our servers. And now we get to the next example we have, and this is how to get a PDF with your results into your code, and also how to you can download the PDF. Therefore, we get to the example get PDF. Here we see again we have our token, and this one requires the token again, and then we print in our method PDF result is get load zone PDF result, and have these different parameters. They are in this type. You have to use these parameters, but we might restructure this so you can get the active layer without having to type it in and having to make some optional parameters. Now we will print the result name and also the 41st letters, and we can see here, okay, now we got the first letters sliced, but for me I can't read it. This is because it's a base 64 binary to text encoded. I have another example here where I encoded this, and so we can see the example when I run the script. What I also wanted to highlight is that we have different steps integrated and can see, so for every step, okay, this was quite fast, so we didn't have much time to see the different states it went through. And then we get our PDF that is the same one we might get from the website. Now I will continue with my last example, and this will be this complex example where we're looking at a solar power system. I took this model from the website. This was also an example for parametric modeling. I'm not combining this now with the parametric modeling, but if we think it through, we could use the parametric modeling in combination with our Geo-Zone tool API to have the results for this solar power system for every place we want to design and get the loads accordingly. Herefore, I'm looking only at the loads, the wind pressure. I'm leaving out the forces you have to put on here for this example mostly. This shall be just one example on how this could be done. Let's jump into it. Here I have my Python file. This is photovoltaic, and import the Dlubal API 6 API. And here I want to write down some steps, and the first thing we see are the input parameters. Here I have my Geo-Zone tool token, the address for the loads, and the height of the module, and the angle and the terrain category. Also, we have here this blockage ratio, what is needed here in the national annex for Germany. Let's look what we have in AFM 6. Here we have this system modeled. Here we have a surface where we put our loads on. This is just for the example. You could put this on any structure you want. And we already have the dead load. Okay, let's jump back in. We have here our first step where we compute the wind values. We import it here from another module, and this one is here. I've separated these two. Here we have the part for the Dlubal API, and we import our wind values over here in this script. We're looking at wind loads for freestanding roofs according to the DIN N 1991-14. And let's see what this script does. First, here we have the load data. We're going to fetch the fundamental basic wind velocity. In the next chapter, we have the table input from the standard. I didn't put this in all by myself. I put some help in. I got some help from modern tools, but here we have the terrain category and how to calculate peak velocity pressure and other values. We also have it here, the different angles, so that we have every parameter. I'm not going into detail now because this was too much time. Here we have some data classes, and then we will calculate here the peak velocity pressure according to our height, and then we will get in the end our pressure on our area and also the suction. Here we run it, and I also implemented a standalone test so I can run this as a test. Let's go back to our main script. Here we see, okay, step 1 will compute the wind loads. It will run the script and import all our values. Then they are going to get printed. Step 2 is that we will create wind loads. This will be only 2 wind loads for me. I'm leaving out some examples. For example, the directions are not included, and also not the line loads that might be applied. Then I map the different wind pressures or suction to the surfaces, and in the end we are going to build the surface loads, the Dlubal API. Okay, let's start this script and see what it does. Okay, we have computed wind values, and there we have our results and also some input parameters. Then we have here the pressure for every area and also the suction, and then some load cases created and the pressure and suction on these surfaces. Let's jump back into RFEM 6. Here we should see now these new load cases, and there we are. We have these loads from our location implemented into RFEM 6. In the end, when I would think it through and I might want to sell this module, I might do the full wind loads and implement them. I could also calculate it and automatically get the results and look at them. And yeah, you can use it in RFEM 6 or use it without RFEM 6, but this example was to show how you might combine these two APIs. So this is the end of my examples for today. Thank you all for listening. We're happy to have this new API with this new structure and also the web version. If you have any questions or remarks, feel free to contact us about it. And we will continue our development on this tool, and I'm hoping to present you with some new features in the near future.
Thank you, Eike, for your presentation. At the end of the webinar, I have additional hints for you. For example, to our online courses, there's the RFEM 6 course. It's a course for beginners. Then the Eurocode 2 course for the concrete design with RFEM 6. The Eurocode 3 course for the steel design. The Eurocode 5 course for the timber design. The Eurocode 8 course for the earthquake design. And the AI Masterclass course. You can get an Eurocode course or the RFEM 6 course for free when you submit your customer project and when we publish it. The courses are valued at 199 to 399 euros. You can submit your project when you click at the link here or scan the QR code. Yeah, and you can upload the files on a form. Also a hint to our free online services. where's the Dlubal community, for example. You can ask questions there, and our support team or other users will answer you. You can, for example, download 3D models as a template for your project. You can download the free 90-day trial versions of RFEM 6, RSTARP 9, RWind 3, and RSection. You can find more information on our website, dlubal.com. For example, the recorded webinars, knowledge base articles, for example. And you can ask our AI assistant, Mia, 24/7. Okay, that should be also all from my side. I thank you for your attention. Thanks again to Eike for your presentation. I hope we meet each other in a future webinar. See you then. Bye-bye.